Good afternoon, good morning, and welcome to the Shack of M1GEO. Today we're looking at an Si5351 development board by Kanga. So just flip that around the other way so we can show you a bit about the PCB. So an Arduino shield, and I'll kind of come on to a bit more about that in a minute. You can see it running away there. So the power board's for. I won't unplug it because there's a bit of a demo in a minute. So just a quick whistle-stop tour on what's on the board. This is designed by, in the bottom left there, m0xpd, marketed on the top left by Kanga UK. You can see there, and this board was donated to me to have a play around with, and I've been quite bad and writing my PhD thesis. Haven't had much time, or finishing the PhD up, haven't had much time to have a play. So it's currently Christmas Day, I kid you not. Literally just coming up to midnight. So I can show you that here. Yeah, just coming up to midnight on Christmas Day, Friday the 25th of December 2015, 1:59 in the morning. That's the current time in London. Okay, quickly have a look at this while we're on the computer screen. This is the instructions for the board, so it comes as a kit, and the surface mount bits are, well, not the surface mount, the difficult surface mount bits are soldered on. I'll point out those bits in a moment. You have to just solder on the passives basically, and wind a few coils and the transformers. So that's what the build instructions are like. Very comprehensive, easy to follow, and everything that you need to know is labelled, so no problems with those. Okay, back to the board. I'll show you what's going on. So there's the SI chip here. I think goes from DC to about 160 odd megahertz, and I'm playing here with the 817 whip, which is on 2 meters at the moment, and we'll have a look at that in a bit more in a minute, but show you what's going on that on the demo. But so the reference chip runs at I guess 25 meg on these, off the top of my head. It goes into the SI chip, which in turn generates any frequencies you need. So yeah, in I think it's hundreds of hertz steps, so very very useful there. So this board's great. It's got a couple of really useful features on it, a couple of amplifiers here and here, and some transformers and isolation as well, so that these SMA outputs are either isolated from ground or by these two transformers, or they can be connected if you want them to. I've got them isolated at the moment, so probably using this as an antenna not the best idea, but that's what I've got. It seems to be working good enough for the demo. So I got the antenna on there. I had a dummy load on it a moment ago and was messing around just checking the amplifiers. I had a cruddy 20 watt dummy load on there, and measuring around, just checking the amplifier was going okay. Seems to be going alright. Notice it works a bit better on the lower frequencies than the higher. I think that these measure to be a little bit lossy on 2 meters. Probably okay. Lower VHF and HF bands, I haven't checked them yet. So it's just faffing around really on Christmas morning. So that's what we're doing here. I actually started off as a quick afternoon project to get a QRSS, slow Morse modes up and going again for the QRSS reflectors New Year activity evening. So they do lots of stuff over the New Year, New Year's Eve, New Year's Day, and so I thought I'd get this up and going as well. I've always been interested in doing it on VHF, so I figured this was a good starting place. And I've got one of these boards and another by Justin NC7S that bought from him, so I figured that was a good project to get one on two, one on HF, and have a play. So that was the basic idea. Okay, so if I whip over the ICOM 7100 at this point, you should be able to see that there's a damn strong signal on the S meter, which is obviously what we're looking at here from the Arduino. If I turn that up, it's transmitting a sequential multi-tone Hell Schreiber, so it sounds a bit like a broken musical box, but on the waterfall it prints an interesting message, so I'll turn that up. I then show you what's on the computer screen. Apart from a lot of dust in the frequency domain, you've got frequency along this axis of the screen. This is frequency, this is obviously time moving up. So you can see how the sequential multi-tones print out some words. It's a little bit drifty. I've only just fired it up for the video, so it takes a little while to warm up. If you were going to seriously use it on VHF, you would probably need to sort of temperature compensate this little oscillator here. Mount it in a thermal enclosure, perhaps not a bad idea. To the end of the transmission, and the noise will come up on the receiver. We'll start again now. So yeah, that's the basic idea. And that's what I've been playing with. I've got another one, Jason's board here, which is also ovened, so I'll pull that up here, which is a homebrew test jiggy kind of thing. There's another Si5351 on this board here, which you can't quite see, and inside here's an ovened high stability oscillator, and this bit's warm. The inside of here is ovened at about 60 degrees, so it keeps the oscillator warm. This is just warm to the touch here, and then you've got the same three outputs from the Si5351 on this board. You've got two outputs, one here and here on SMA. There's also a couple of jumpers here and here, and just, you can't see them here. Two there and two there, which are the active parts of the signal, ground and the hot signal. And the third output from the chip comes up through here somehow and into this chip here, which is, I can't remember the part off the top of my head, but it's the one they use for Talo mixers and detectors. So you stick a signal in here at frequency F, and you get four outputs, all at 90 degree phases at f/4. So ideal for SDRs and those kind of things that go and feed a Talo mixer. So that's the idea behind that, and I will definitely be having a play when I got a bit more time on that one as well. So watch this space. But at the moment, that's all I've been messing with. But there seems to be a bit of interest on YouTube and on Twitter when I posted a few pictures earlier on. So I thought I'd grab a quick video on the phone and just show people what I've been up to today and how it's working. So yeah, very pleased with the little board. As I say, it's been a long time coming to play with a Kanga PCB, but yeah, doing a good job. I'll get rid of that in a second. I'll show you the board. So I'll unpower it now, and watch my hand remove the SMA. You'll see the boards are standard size Arduino. Sure, it goes with the series, the Kanga series of receivers and transmitters and stuff. So there's a stack they do where standard Arduino, and goes with the stack of shields that have a receiver and a transmitter on them. And there's what they call an RF, common RF bus or something on here, an RF expansion socket, which has got all the RFE signals and ground padding around it. So on the other side, not much at all on here. Really, all the interesting bits on the other side, lots of just jumpers and links on this part of the board, and one little mod that I put on the little track that just specifies the I/O voltage for the I2C bus. So where am I? Get the board up the right way. Yep, this way around. So these two here, last two pins are a serial clock and serial data. A couple of jumpers which selects whether it's this board is being addressed, or you may have other boards and tack on wires or something. So these two, try and get that to focus a bit better in the dark. That's better. Okay. So these two boards, these two jumpers are serial clock and data, and you've got these two FETs here are doing level converting from the 5 volts on the Arduino to the 3.3 volt that this system's running at here. Over here is running at 3.3 volts. So there's a level shifter, bidirectional level shifter here, and the jumper that I put on the back just tells it this domain is 5 volt. just feeds a couple of pull-up resistors here. So that's all. I say, very pleased with it. Works very well. Took a little while to build. Took me about, I guess, about an hour and a half to build, and just sort of plodding through one evening, listening to a bit of music and soldering the parts down. Instructions are easy to follow. Just nailed the bits on an order and fired it up, and it worked perfectly. So there we go. Can't complain. No problems on that one. And definitely will be used in some more projects to come as well. Hopefully you'll may even hear it on air over the coming weeks. Keep an eye on the my Twitter account, and check back on here YouTube for a few updates. I'm sure there'll be a couple more clips. But there we go. It's a bit better. So yeah, really nice board. A great sort of interface with the Arduino bits, and lots of things thought out that this doesn't short out on that, and well thought out, which I've had that with many a thing before. One board, in fact, a hand, not quite as well thought out, is this Ethernet shield, which you may be able to see I've put a bit of plastic on because the pins here short out on the back of the Arduino. So there you go, well designed board, works very well, thoroughly recommended, and you'll hear it on air for sure very soon. There we go. Sorry for the long waffly video, but a few people seemed interested in what I was messing with, and I thought I would bestow the virtues of these sort of little boards as well, working really well. So that's it. I'll be writing a proper update, less waffly update on the website. So keep your eyes peeled. Cheers for now, and 7-3 from Czech of M1GEO. Cheers.